Okay, in this video we're going to revisit stuff that we spoke about back in National 5 about roots of quadratic equations and the discriminant. Now back in National 5 we looked at three rules to do with the discriminant, which is that value underneath the square root as part of the quadratic formula, which says b squared minus 4ac. So in National 5 what we learned was that b squared minus 4ac is bigger than 0, we get two real distinct roots. Whenever the discriminant is equal to 0, we get one real repeated root. And if the discriminant is less than 0, then we get no real roots. Okay, so you remember those from National 5. What we need to now do is just take this and use it to solve problems in higher. So let's look at example 11. It says, find the value or values, that bit in S there says it could be one or more than one value of p, so that the roots are equal. Okay, so the key word here is roots and equal. So what I want to think of when do I have equal roots? Well, the second bullet point tells me that. I get equal roots whenever b squared minus 4ac is equal to 0. So let's say that. So I get equal roots when b squared minus 4ac is equal to 0. So let's pull out the values of a, b, and c. So a is equal to 1, b is equal to p, and c is equal to 4. So let's substitute that into the discriminant equation. So that'll be p squared minus 4 times 1 times 4 is equal to 0. So that'll be p squared minus 16 is equal to 0. So I get p squared is equal to 16. So p is going to be the square root of 16. So p is going to be plus or minus 4. Please remember that when we square root a number, we always get a positive and negative value. Okay? Let's look at example 12. Find the value or values of p given that 2x squared plus 4x plus p has real roots. Now, if you look at the bullet points above, we get real roots whenever b squared minus 4ac is bigger than 0, but also we get real roots whenever b squared minus 4ac is equal to 0. So I can say that we get real roots when b squared minus 4ac is bigger than or equal to 0. So let's pull out the values of a, b, and c. So a is 2, b is 4, and c is p. So let's put that into our expression here. So I get 4 squared minus 4 times 2 times p is bigger than or equal to 0. So that will give me 16 minus 8p is bigger than or equal to 0. Now this is just a normal linear inequality because the value of p has got a power of 1. So I don't need to solve any quadratic inequality. I don't need to draw a sketch. Just normal rules apply from National 5. So I get minus 8p is greater than or equal to 0. Nope. Let me just undo that. Negative 8p is greater than or equal to negative 16. Divide by negative 8. So I get p is less than or equal to positive 2. Don't forget, whenever you divide by a negative, the inequality symbol always flips round. Okay? Example 13. Find the value or values of r, given that x squared plus r minus 3 times x plus r has no real roots. So again, let's go back to our bullet points. So I get no real roots when b squared minus 4ac is less than 0. So let's say that. So the key word there are no real roots. So I get no real roots when b squared minus 4ac is less than 0. These are things that if you don't know by memory by now, you really will need to know. Okay? So no real roots whenever the discriminant is less than 0. Let's pick out the values of the discriminant. So a is equal to 1. B is equal to the value that's multiplying x, which is r minus 3. And c is equal to the value that's left over, and that's just going to be r. Okay? So put those values in. So I get r minus 3 all squared minus 4 times 1 times r is less than 0. So let's expand this and simplify. So I get r squared minus 6r plus 9 minus 4r is less than 0. So I get r squared minus 10r plus 9 is less than 0. Now this gives me a quadratic inequality to solve. So let's go to the side and solve the equality for r squared minus 10r plus 9 is equal to 0. So 1 times 9 is 9. Two numbers that multiply together to give me 9 but add to give me negative 10 will be negative 1 and negative 9. So that'll be r squared minus r minus 9r plus 9 is equal to 0. Many common factorise, many common factorise. So that'll be r bracket r minus 1 minus 9 bracket r minus 1 is equal to 0. So that'll be r minus 9, r minus 1 is equal to 0. So r is equal to 9 and r is equal to 1. Because it's a quadratic inequality we're solving, we must sketch the graph. So this is crossing the x-axis at 1, or the r-axis I should say, at 1 and 9. It's a positive r squared, so it's going to be a happy face parabola. And I want to know when is this graph going to be less than 0? It's less than 0 when the graph is below the x-axis. So that's after it leaves 1 and before it approaches 9. So that's going to be when r is bigger than 1 and when r is less than 9. Because I have overlapping values of r, I get 1 is less than r, which is less than 9. Okay? So that means that the values of r, which gives this equation no real roots, are the values of r between 1 and 9, but not including 1 and 9. Okay?